Okay, we're going to do a quick review of using the greatest common factor to factor polynomials. We learned how to find the greatest common factor before by finding the prime factors, and you should have that in your notes. I'm going to show you a quick way to do that because you need to be able to find that greatest common factor quickly for these types of problems. First thing you do is you look at the coefficients of the two terms, and we have 9 and 36. And we know that the greatest common factor of 9 and 36 is 9. Okay, and then we can look at the variables, and we have x squared and x, and the greatest common factor for those are x. Okay, so our greatest common factor for this polynomial is 9x. To factor the polynomial, we have to divide both terms in the polynomial by the greatest common factor. We pull 9x out front, and then we're going to divide by 9x. Okay, and 9x squared divided by 9x leaves us x, and 36x divided by 9x gives us 4. Okay, so the fully factored polynomial is then 9x times x plus 4. I can check my work by distributing the 9x again. So 9x times x gives me 9x squared, and 9x times 4 gives me 36x. And since I ended up with the same polynomial that I started with, I know that my factored polynomial is correct. 9x times the quantity of x plus 4. Okay, let's try the next one. 16xy minus 40xy squared. Again, to find the greatest common factor, I have to look at 16 and 40. And the greatest common factor for 16 and 40 is 8. Okay. Then I look at my variables. I have x in both of those terms, so that since they share that x, that's a common factor. Then I also have y and y squared, and then both terms share one y. So my greatest common factor is 8xy. Then I'm going to divide both terms by 8xy, and I end up with, I'll pull 8xy out in front again like I did before. Okay, 16xy divided by 8xy is 2, and then 40xy squared divided by 8xy is going to leave me with 5y. Okay, and to check to see if my answer is right, I distribute the 8xy again to both of the terms. 8xy times 2 is 16xy, and then 8xy times negative 5y gives me negative 40xy squared. And again, since it's the same polynomial that I started with, I know that I have factored it correctly. All right. I'll do one more example, and then you can do the last one at home. So, to find the greatest common factor, I look at 24 and 36, and the greatest common factor for 24 and 36 is 12. Okay. For my variable of m, they both have m squared. They each have one n, and they each have one p. So the greatest common factor is 12m squared np. And I know I'm going to divide both terms by the greatest common factor. and I end up with 2p for the first term. We can remember these skills from earlier in Unit 6 when we were dividing monomials. And you can go back in your notes and see these skills if you're not sure about them. 36 divided by 12 is 3. M squared, I have an n here, so I end up with 12m squared np times 2p plus 3n. And I'm going to distribute to check my work. And I end up with 24 m squared n p squared plus 36 m squared n squared p. And again, I ended up with what I started with, so I know that I have factored this correctly. And if you'd like to take a minute and stop the recording and solve the next problem, I will show you the answer when you turn the recording back on. Stop it now. Okay, hopefully you finished that last problem, and I'm going to share with you the solution that you should have had. The greatest common factor is 2ab, and when you factor it, you should have 2ab times a squared b plus 4 plus ab squared, and you should have checked your work. And very quickly, to factor polynomials, you first find the greatest common factor, and then you divide each term in the polynomial by the greatest common factor. Always remember to check your answer to be sure you have factored correctly.